So today another IMRC module, so why not try to fix it? And when fixing it, why not make a video about it? This controls the intake manifold length in a car, and let's try to unscrew the screws and see the internals. 4 screws here. The screws are out. Can I remove the cover from it? I have to pry a bit. And it opens. And it's probably the same type or very similar to the one I already repaired. Previously it was a bad diode. So let's remove the board and we will have to desolder the connector. We removed 5 screws, plus 1 screw for the transistor. The transistor uses the housing as a heat sink. And now desoldering time, of course. The 6 pins of the connector are desoldered and we can take the board out. It seems to be the same as the previous one, and there's really not much to it. There is a motor, it turns these gears and it pulls this steel cable basically. And this thing moves in. And it moves a flap, changing the intake airflow. And here's the motor. We can test the motor and then the components on the board. Just the discrete components and one 8-pin chip through hole. Let's set my bench power supply to 12 volts and 2 amp current limit. And let's connect this to the motor. It seems to work. It doesn't draw much. This is a 2 amp range. Let's try 1 amp range. About 200 milliamps. And now let's test the components. Let's start with the diodes. In the previous one the problem was this diode open circuit. But this one is... Diode is in forward, drop about 0.5 or 0.6 volts. So this one is good. This diode, good. This diode, good. This smaller diode, good. And there is a zener. I can also test it in forward. And it seems good. It's not open circuit or short circuit. There seem to be some tantalum capacitors, so let's check them for shorts. No short circuit here, no short circuit here. Now of course the transistor. It's an NPN Darlington transistor, base to emitter. Typically it's about 0.6 volts, but it's a Darlington, so it makes sense to be a higher voltage drop. Base to collector, seems good. Collector to base, nothing. Emitter to base. I guess this is a diode in the circuitry or the chip. It's not in the transistor. Collector to emitter, this should be open circuit unless the transistor is shorted, and it is open circuit, so the transistor is not shorted. And emitter to collector, and there is probably some internal or external anti-parallel diode, which seems good. Now let's switch it to resistors. There's a 1.2 kilo ohm resistor, which seems good. The other one is the same, again good. A 270 ohm resistor here, which is good. There's a very low resistance resistor, black, green, silver, 0.05 ohms. This is a current sensing shunt for the motor and it's not open circuit, so it should be good. So I basically tested all the through-hole components except the chip. Maybe the contacts I should test. And they're making a contact, they're not bad. And the transistor is not shorted, but it still could have some other problem. Now let's go to the other side of it. Some SMD capacitors, resistors, a diode. So let's start with the diode. And there is some annoying resin on the board. It's not easy to make a contact, but this diode is good. Checking the ceramic capacitors for shorts. It's not 0 volts, so it's good. This one is, but it's actually parallel to the motor, I guess. Or the current sensing shunt. This one probably as well. I have to look what's on the board. This is not shorted. This is not shorted. Not shorted. Of course it's confusing to measure components in the board. This capacitor is connected parallel to this current sensing shunt, a very low resistance, so it appears shorted. And this capacitor is parallel to the motor, so it again might appear shorted, but it's actually not. Now some resistors, 330 ohms, good. This one is 75 ohms, close enough. This is 150 kilo ohms. And some capacitor charging and skewing it a bit, but it actually gets to 150 about. So it's also a good resistor. Now let's check the small transistor. I don't remember what it was the last time. This is collector to base, so it appears PNP. Base to collector, nothing. Emitter to base, and base to emitter. And there is a 330 ohm resistor between the emitter and base, which is of course skewing it. Here is the resistor, emitter to collector, collector to emitter. Now the resistor is skewing it. The current actually flows collector to base. And the transistor isn't shorted. And if it's open circuit emitter to base, I can't see it because of the resistor. But typically transistors fail short circuit more often. I don't really see anything bad so far. But of course some failures in a transistor can't be tested in a board. Or can't be tested using a diode test. I will desolder the transistor and put it in a transistor tester. And I will also try to test it using a tungsten lamp and a bench power supply and see if it can switch high currents. The transistor's out, here's the marking of it. Let's see what the transistor tester will say. It says bipolar transistor, gain 38 only. It's a Darlington, it should be more. It should be a couple thousand, I guess. As the base to emitter voltage drop is high, which is normal for Darlington transistors. But maybe the transistor tester just can't test it. This is very often the case when the transistor has a built-in base to emitter resistor. I've put the transistor on a temporary heatsink. I'm using a tungsten lamp, 21 watts, 12 volts as a test load. Let's give the transistor some base current. It's getting 3.8 milliamps of a base current. And it's switching 1.68 amps. And it's probably in saturation already. Here's the collector to emitter saturation voltage. And at 0.18 milliamps into the base, the collector current is 1.4 amps, and it's not in saturation. The collector to emitter voltage is 3.9 volts, and we can calculate the gain from this. This seems like a good bipolar NPN Darlington transistor. I tested almost everything and I don't see any obvious bad component. The previous one was easy. It was this diode, 1N5404. It was open circuit, I replaced it and it was working. But here the diode is good. It says 0236. So this one is even older than the previous one. This one is from 2002, I guess. This also says 02. It's 2002, week 29. Let's try to connect a bench power supply limited to 2 amps to this diode in forward and see the voltage drop. 0.84. A normal voltage drop for silicon diodes at higher current. I also tested this one at 2 amps, this one at 1 amp and this one at 1 amp. And all of them drop about 0.8 volts. No bad diode here. It could be a bad chip, but it's not easy to test. Or maybe a solder joint, a weak motor, or maybe it's just not lubricated enough. Or of course the problem can be somewhere else in the car. In the previous identical module it was this diode open circuit. After replacing it, it was put back into the car and it worked. This thing demonstrates that the same thing doesn't have to always have the same failure, and the problem isn't always as easy to find. I added a new solder on almost every solder joint here, because they actually looked quite crappy. It might have been a bad solder joint. Checking the ESR of the capacitors, but these are tantalum. A high ESR is typically a problem of electrolytic capacitors. And this is less than 1 ohm. This is acceptable for low capacitances. These seem to be 10 microfarads. At least the one where the marking is not facing the board, of course. Connecting 2 amps to the current sensing shunt and it's dropping 0.1 volts. Let's just boast of my online calculator. I call it a calculator and yes, the current sensing shunt is 50 milliohms or 0.05 ohms if you want. Everything's moving freely here. The gears have no broken teeth and they're made of metal, which probably wouldn't be the case in a newer car. Let's relubricate everything. No problem in the contacts. This tester can supply about 4 milliamps. I'm hooking it on the probes of a multimeter set 2 volts and now let's measure the voltage drops of the transistor. 0.7 volts. Now it's enough current to overcome this resistor. Here it's 1.2 volts dropped on the resistor, and here it's the voltage drop of the base to emitter, or actually emitter to base junction of this transistor. It's PNP and the collector to base. The other way the transistor is not conducting at 10 volts. And you can see the voltage drop a bit higher at about 4 milliamps. Normally a diode test is using about 1 milliamp. And this also can be used to test a Zener, but I guess there is some other circuitry pulling the voltage down here. In forward, it's a normal voltage drop of a diode. Let's try to use 100 milliamps from my bench power supply. Hooking this to my voltmeter probes and let's test the Zener. And it's dropping 5 volts. So is it something like a 5 volt Zener? They make 4.7, 5.1 and then 5.6. What if I change the current to 50 milliamps? Does it change? If it's a resistance, halving the current also halves the voltage drop, whereas on a zener, halving the current makes almost no difference in the voltage. I'm actually measuring the zener voltage, not some other load, definitely not resistive. Let's try 200 milliamps, and it shows 5.2 volts, so it's probably a good 5.1 volt zener. I really tested absolutely everything I could think of testing here. Let's put some heatsink compound under the transistor and reassemble it and see. If it still doesn't work, it's either the chip or something else in the car. Testing it at just 6 volts. Even at 6 volts the motor can move it. Let's solder it back. Let's put the cover back and it has to be tested in the car. And the screws are back and that's it. This was quite a deja vu video. It would be much more interesting if it was a different type, but anyway. At least it demonstrates that the same type of device might fail a different way every time, and that the diagnosis doesn't have to be always that simple. It will go back into the car and I will put an update into the description whether redoing the solder joints and relubricating it helped or not. And if you like my videos, please consider supporting my channel on a Patreon, using the thanks button or subscribing. And big thanks to all of you who already support me, because this keeps my channel running.